let's keep developing our skills with calculating a partial derivative of a function of two or more variables. So I want to take us back to a key concept of Calculus 1. If, for example, we had a constant multiplied by x to a power, and we wished to find the derivative of that function, the power rule is used, but also something called the constant multiple rule, or the constant multiply rule, which means the derivative is the derivative multiplied by the constant. So it would be the constant times n times x to the n minus 1 power. I cannot stress enough, when you're doing partial derivatives, you must keep track of the constant. You have to keep track of it. So if we have, for example, a function of x and y is 7x to the third y to the fourth, and you are asked to find the partial derivative of that function with respect to, let's say, x, that means that we treat y as the constant. So this right here is saying x is our variable. So this y to the fourth is very much like the 7 that's here. It's just the constant in front of the function when we do this calculation. So it's going to be 3 times 7, which is 21, x to the second power, y to the fourth. And if you want to, the y to the fourth could be in front. It doesn't matter. But most of our Western world algebra teachers say, let's put it in alphabetical order. But multiplication is commutative, so the order can be reversed. And then as soon as the other version of the question is asked, what is the partial with respect to y, we go back and reset our thinking. Now y is our variable. So 4 times 21 is, 4 times 7 is 28. X cubed is just a constant that stays there, and that'd be y to the third power. So we really have to stay focused on which is our variable, what's our constant, and also keep track of our two separate problems here, because here's one and here's another. Let me show you this. In some ways this is going to look simpler, but experience tells me this is the one where it's easy to make the mistake. Here comes the next function. All right. So z, oh yeah, z, another name for f of x, y. If I want to take the partial derivative with respect to x, that means y is just a constant. So you can almost write the problem so we have our x and then we have our 7y constant. What's the derivative of x? Well, that's right, it's just 1. So we have 1 times 7y, which is just 7y. If I then reverse the question and ask for the y partial derivative, well, now y is the variable and 7x is the constant, and the derivative of y is just 1. I'm going to write it this time. Don't focus on what variable is remaining. Focus on the variable that you're going to take the derivative of. Y is the variable, the derivative of y is 1. If x is the variable, the derivative of x is 1. Sounds simple. Must practice lots. Let's do that. F of xy is x divided by y. Let's find the partial with respect to x, and then we will find the partial with respect to y also. You know, you don't need to write it as a fraction and make yourself suffer if fractions cause you to have little distractions that get in your way. You could write this problem as x multiplied by y to the negative 1 power, and then it looks more like the problems that we've just looked at. Now if x is the variable, the derivative of x is just 1. This is a constant that doesn't change. 1 over y is our result. If y is the variable, then we get negative 1 times x times y to the negative 2nd power, which is negative x over y squared. Now I tell my students, if they can do this math mentally, I don't have a problem with it. They've already gone through more than one semester of calculus to get here. That could be very simple for them. Experience tells me that when we start stacking information on top of this, skills that may not be difficult are easy to mess up because we convince ourselves that we got this. Not necessarily going to happen the right way every time. Alright, moving forward, let me show you another one. Alright, here we go. We have sine of x squared y to the 5th. If we take the partial derivative of z with respect to x, we are now looking at a chain rule. And the derivative of sine is indeed cosine. But now we need to multiply by whatever the derivative of this expression is if x is the variable. So that's x squared derivative of x squared. So that's going to be 2x y to the 5th. Now a textbook will not leave the solution written like this, but it's multiplication, and the order should not matter in multiplication of numbers. And we got here 2x y to the 5th cosine of x squared y to the 5th, if you want to write it in that order. And if I reset the problem, the first part of the problem won't look any different. It's still the derivative of sine. But now, when we look at this expression, we have to ask ourselves, well, what is the y partial derivative of that? The x squared is a constant, and the derivative of y to the 5th is 5y to the 4th. Technically, this is not an illegal answer, but I think most of us would say that if you were to look it up or ask an instructor, it's usually going to look like this. Cosine x squared y to the 5th. It's kind of messy. All right, let's try another one. Now I am going quickly. My expectation is you would pause and try it before I even get to it. You already know I'm about to do two partial derivatives. You should try first. If you can calculate these correctly before I do the replay, you're well on your way to having the skill mastered. And then if you can't, then you start to identify, well, which type of problems get me messed up. If you're just watching and smiling and nodding like you understand, nope, watching the episode won't count. All right, x partial derivative and y partial derivative coming up. Please note, I'm getting a little bit lazy with my notation here. But if you start to see more parentheses and x's and y's, I think your eyes are going to, well, you're going to just pause and quit the whole video maybe. All right. If x is the variable, we have ourselves a situation. This has an x in it, and there's an x here. This is going to be a product rule. There's two parts of this expression that have x that are being multiplied together. So the product rule says the derivative of the first function, which would be 1, leave this second function alone, plus leave the first function alone, and then we have to remember how to do the derivative of tangent. That's secant squared xy. And then we have to figure out what's the derivative of xy. Now don't just flip a coin and guess. If x is the variable, the derivative of x is 1, leaving you just the variable y there. I'm going to suggest leave it like that. Leave it in its raw form. That pre-algebra teacher that says don't write the 1 in front, no, what they said was you don't have to write the 1 in front. We can write the 1 in front. Computer nerds aren't going to ignore that there's a 1 there. When they program, that 1's there. So, partial derivative. If y is the variable, that was the time to pause me, just so you know. There's no product. There is no product. This is just a constant. It's like having a 2 in front of the tangent. The derivative of this is just going to be x times the derivative of whatever tangent is, which is secant squared of xy, multiplied by, if y is the variable, the derivative of y is 1, leaving me with just an x. Okay, I'll honor the algebra teacher this time. That probably is the cleanest way to leave it. I know there's a lot here, and it starts to all blend together. Pausing is a good thing. I'd like to show you a couple more in our next segment, just to make sure you get some additional practice. So stay tuned, because I haven't shown you all of the little algebra tricks and all the types of functions, but I want to try to get a good cross section before we move forward. Okay? Until next time.